Hello friends, myself Sachin Kumar. Today I am presenting very interesting video on time complexity. Basically here I am presenting 5 rules, and after implementing these rules we can find out complexity of any algorithm. So if you are new to our channel, please like and subscribe. What are these rules I am presenting now? So first rules depends upon the number of fixed steps. If your algorithm is executing in fixed number of time, then constant time complexity will be there. In this case, we can write complexity is order of 1. I mean, number of steps are fixed. Number of steps are not varying. Number of steps are not depends upon the any variable just like n. So in this case, complexity is order of 1. Second rule is here. If we have n size problem and n size problem is divided into almost two equal parts. Say we have here n size problem. This n size problem is divided into n by 2, then n by 4, etc. So in that case, complexity is order of log n. Second case of this may be if we have loop and every time loop variable is doubled. I mean initially I equals to 1, then I equals to 2, then I equals to 4. So in that case further complexity will be order of log n. Rule number third, if number of steps depends upon the n, then complexity is order of n. Fourth rule, if number of steps depends upon order of n square, then complexity will be order of n square. If number of steps are exponential, then complexity will be order of 2 raised to the power n. So total we have here 5 rules, and if we are able to implement these rules on any algorithm, then we can find out complexity in very easy manner. Now I'm presenting few examples so that we can calculate the complexity of the algorithm. Example number 1. If we have here, say I loop is here and this loop executes n time. I equals to 1, then I less than equals to n, I plus plus. Here loop is executing n time. So dependency upon n, I mean simple relation is upon n, how much time this loop is executing. So dependency upon n. So if we have the dependency on n of any algorithm, then complexity is order of n. So in this way, we can find out the complexity of this algorithm. Now, I'm presenting here example 2. In this example, we have here two for loop. This is the first for loop and this is here second for loop. So here, this for loop, first for loop, outer for loop executes n times, and inner for loop also executes n time. The total times this loop executes n multiplied by n square. So dependency is upon n square. So we can say complexity is here order of n square. So dependency upon here on n square. N from this loop and n from this loop. If we multiply n by n, then this term is n square. Therefore, complexity is order of n square. Now, I'm presenting example 3. Here in this example, we have here further a loop, and this loop initially I equals to 1 and value of I less than equals to n, and at each step I is doubled here. Say initially I equals to 1, then I equals to 2, then I equals to 4, then I equals to 8. So if at every step loop variable is being doubled, then we have complexity order of log n. So in this way, we can find out the complexity of this example. Now, I'm presenting one more example. Here, initial value of I equals to n and I greater than equals to 1 and I equals to I by 2. So here at every step value of I is half. Initially n, then I equals to n by 2, then I equals to n by 4. So at every moment variable value is being half. So in that case further complexity will be order of log n. Now I'm presenting another example. In this case, we have here a for loop and I equals to 1 and I less than equals to n square. So here this loop executes n square time. So dependency upon n square. Here we have only only single loop. No inner loop is here, but still this loop is executing n square time. So therefore, complexity will be order of n square. So we have to find out the dependency basically here. So dependency upon n square, not n. So this is very interesting point here. So complexity will be here order of n square. Say, in the example 6, we have here I equals to 1 and I less than equals to 10 and I plus plus. So here, dependency upon constant time, dependency upon not n. So this loop executes fixed number of time, not n. So number of steps are here constant, number of steps are here fixed. So therefore, complexity will be order of 1. Now, we are presenting one more example, example 7. So here we have a loop, for loop. This for loop executes n time. Initially I equals to 1, then I less than equals to n, and every moment value of I is increasing by 1. And within this loop we have one more loop. This for loop is j equals to 1, j less than equals to n, and j equals to j by 2. So at every moment j is doubled here. So therefore, complexity of this particular J loop will be order of log n, and complexity of this I loop is here order of n, because it executes n times dependency upon n. Here dependency upon log n. So therefore, complexity will be here order of n log n. And say we are presenting here example 8, and this is our here final and last example. Here initial value of I equals to 1 and I less than equals to 2 raised to the power n. So dependency here upon exponential time. 2 raised to the power n is here exponential time. So therefore complexity will be here order of 2 raised to the power n. So in this way, we can find out the complexity of any algorithm. So basically here, our observation is here, we have to find out a dependency. If dependency is on constant time, then complexity will be order of 1. If dependency upon log n, then complexity will be order of log n. If dependency upon n, then complexity will be order of n. If dependency upon n square, then complexity will be n square. If dependency upon n log n, then complexity will be n log n. If dependency upon exponential, then complexity will be 2 raised to the power n. Thanking you.